lightning implementation of the Nanopass framework for Haskell that Michael Adams and I have been working on since sometime yesterday afternoon. So first, briefly, who am I? So I'm not much of a Haskeller at all. I'm actually more of a schemer. And I actually spend most of my time now working in industry. But you may remember a talk that I gave back at ICFP a couple years ago. We took SheScheme, which was an 11-pass compiler. We turned it into a 57-pass compiler using the Nanopass framework. But of course, we did all of this in Scheme. Now, how did we do this? Well, we had a little language for ourselves that gave us a way to define new languages, a way to create new languages from old languages by defining a small delta on that language. And then we could define passes over these languages that would let us make small changes and have the passes fill in boilerplate for those things. Since then, I've had several friends who are in the Haskell community who have asked for something similar to this in Haskell. And so Michael was kind enough to give me some of his time because my skills in Haskell are not so great. But we've implemented something that uses Haskell data types in order to get you to your language definitions. You can define a new data type based on an old data type, and this is using template Haskell to make this happen. And then the template Haskell is also generating for you forward and backward functions that are partial functions from the old data type to the new data type, where the constructor for the old data type and the new data type are matched up, and when they match, and when there's not one there, you get an error. And then you can use these forward and backward functions in order to implement the parts that aren't your boilerplate. So to give you an example of how this works, we have a small language here. You'll notice it's not much of Scheme, and it has random stuff thrown in that's weird. But the important thing here is that we're going to eliminate our cons and replace it with an allocation that's going to allocate some space and put some things into those spaces. And so we do this by using our new defined data type, which was provided from our Nanopass framework module here. We simply define a type delta here. It gives us our input type, our forward function, our backward function, a name mangling function, which is what to do with our constructors from the output or from the input data type that we're turning into our output data type, a list of constructors that we're removing from our original type, and our new data type that's going out. And with this, we can simply define now our expose alloc pass that matches our cons, expands into what we want it to expand into, and uses the forward function in order to provide all of the rest of the functionality. Now, if we didn't have our defined data type, we would have to define our new data type this way. This is the same data type that it's generating. And we would have to define all of our expose alloc code. And as you can imagine, this gets more complicated the more complicated your languages get. So we actually have all of this running as of this morning. Well, as of yesterday for Michael's part, as of this morning for my part. And it now does the exposes this allocation. I ran this in GHC and cut and pasted it into here. But if the Nanopass framework in Scheme and Racket is currently a tree, we just have a sprout of it in Haskell right now. And so we need your help. You can volunteer to help out with this stuff. My email address or my Twitter. We have the repo up. You can actually already pull this stuff down. And if you're interested, take a look at it. It would be great to hear your feedback. Thanks very much.
So a long time ago, in a galaxy far, far away, I used to do game development and license company to game companies. And every once in a while I get bored and I start playing around with graphics again in Haskell because it's my happy place. Last time I did that, we